Hello everybody, welcome to Unit 3, Section 3, where we're going to cover how to process 2D arrays. Your learning objectives for this section is to be able to process individual or multiple elements of 2D arrays and be able to pass 2D arrays into functions. As a refresher, a 2D array stores data that can be thought of to be in a table format, and by that I mean the data is organized into rows and columns. This segment of code declares a 2D array X with 2 rows and 3 columns. Inside of memory, however, things are a little more complicated. The 2D array X is actually a 1D array of 2 values. Each of those values is a memory location that points to their own 1D array of 3 items each. Index 0 and 1 of X. Each is an int array of its own and holds the address of an array of 3 ints. In order to process a 2D array, we use a nested loop in what's known as row order traversal. And here's what the shell of that nested loop will look like. First, we iterate through the rows starting with the 0th row index. Then we iterate through the columns, again starting with the 0th index, and then we move to the next column index. Then we move on to the next row index and repeat the processing of each column index. And again, we move to the next row and continue to process each column until we have covered every element in the 2D array. One common use of a 2D array is image processing. This is because a 2D image is naturally a 2D array of pixels, with each pixel representing one dot in the image. You've probably seen this blur as an image functionality in image processing software, and this is done by iterating over the 2D array, modifying each pixel based on what surrounds it. Image blurring is done by applying a predefined 3x3 weight mask on each pixel and its 8 neighbors. For this example, we'll use the following mask. Here you can see the center value of 2 will be used for the weight for the center pixel, and the values around it are its neighbors. Different blurring algorithms may use different weight masks. The new value of each pixel after blurring is its weighted average of the old values. Specifically, we multiply each old pixel value with its weight, add those products together, and divide the sum of the products by the sum of the weights. In this case, the sum of the weights is equal to 14. So for this example, given the weight mask and this 2D array, the new value of the element at row 2, column 2, which is right here, will be calculated like this. So 24 would become the new value at index 2, in the new image. Now, the hardest part about working with the mask is figuring out how to get the neighbor values. If you recall our row ordering processing algorithm, you'll remember that we have rows and column indices. That means we can reference the target values of the neighbors just by incrementing and decrementing by 1. If this index is our target, then its upper left neighbor is simply the row minus 1 and the column minus 1. And the lower left neighbor would be the row plus 1 and the column minus 1. Pixels that make up the border will not have 8 neighbors. For those pixels, we have 2 different options. One approach is to skip those pixels and just use their old values. And another approach would be to calculate their weighted average using only the available neighbors and their weights. For example, the element at row 0, column 0 in this 2D array only has 3 neighbors. You can see that right here, 11, 12, and 2. So let's look at an example for using option 2 for this. Here we will only use the corresponding weights in the calculation. And this would be the result of using approach 2. You can see that our sum of the weights is different now, right? It's not 14, and we are adding fewer variables or fewer items to get our sum for the new weight right here. We're not calculating these neighbors right here. Now, in order to use 2D arrays in your functions, you'll need to know how to pass a multidimensional array into a function. This is how we pass a 1D array into a function. The first one is an example by a const reference, meaning we won't be modifying the values, only reading them. And the second one is by reference, indicating that we will be modifying the values. So you can see this one here says constant, and this one just says int. You should always pass in a size parameter together with the array to tell the function how many elements the array actually holds. So you can see here our int size in both functions. Also remember that the arrays are passed into functions by reference by default because a pointer to the first element is passed. Now this is how we pass a 2D array into a function. For a 2D array, a pointer to the first element is passed into the function. Here the first element is an int array of 5 slots. You must specify the column dimension size. So you can see here that the row size is optional, but we have to pass in the column dimension size, and then we're passing in the row size as a variable. Similarly, this is how we would pass in a 3D array to a function. Okay, you can see it follows the same format where we are passing in the first dimension size as an argument, and then we are giving the additional dimensions in the brackets. Now it's important to note that you can only skip the size of the first dimension when passing the array into the function. However, you should always pass it as a size parameter. Okay, and this is going to be confusing when you first are using these. Is you have to remember that you pass in the first size as an argument, but any additional ones you pass in using the brackets. Let's walk through an example code of using a 2D array. So I wrote this program really quick just to use it as an example. So you can see here we have our main method, and in our main method we're going to call 3 different functions: fill array, print array, and sum array. Okay, and then we can see up here that our method declarations, we have those where you can see that we're passing in an array and the size of the rows, just like we talked about. Same thing with the print array. Now this time with the print array, we are not changing the values, so we're passing it as a const, right? But the same thing applies. We're passing in an array, and we're specifying the number of rows, and then our columns is the second parameter, just like our first one. And the third one, we are going to be summing the contents of the array. And again, we're not changing the values of it, so this should be a const array, right? Now, if we change the header and we don't change the definition, okay, what's going to happen? Well, if we compile it, you can see there we get an error, okay? And so what we got to do is we come down here and we say, oh, this needs to be const as well, all right? So we fixed that problem because we're not actually modifying the value of the array when we add it. So let's take a look at the functions that we've created and walk through it, and you can see here we have the standard algorithm for going through the array, or what we've referred to as row order traversal. So for each row, we're going to go through each column, and then we're going to assign it a value. And in this case, we are just assigning it a random value between 0 and 9. Okay, and that's it. That's how we go iterate through the array. All right, so that's the first step of our main method right here. You can see we're declaring our array of size 4 rows and 5 columns. And again, I had to use constant ints because we cannot use variables to declare our array size. Okay, you can see how when I take the const out, everything lights up like a Christmas tree. Okay, well, that's because we didn't use a constant variable to declare those array sizes. Okay, so now everything's happy. So we've filled the array, we declared the array, but it's blank, and we've printed the array, or we filled the array, excuse me. Now let's print it. Well, this is the same thing, except for we're just adding in some extra print statements in between our processing. And this is just to get it to print out in a nice grid-like fashion. But we're doing the same thing. For every row, we're going to print out a bracket. And before we start, we're printing out a bracket. And then we're just going to iterate through all of the values. And we're going to print out what that value is. And if it's not the last item, then we're going to add a comma, right? And then when we're done with that row, we're going to add an end brace, or an end bracket, excuse me. And if it's not the last row, we're going to add a comma, right? Otherwise, if it is the last row, that means we're done with the whole double array, or 2D array. We're going to finish it off by adding in a bracket at the end, okay? And then an end line. So that's all the array does, or the print array. It just goes through and prints it out, right? And just like that, again, third example, same row order traversal. We're initializing sum to 0. We're going through each item, and instead of assigning a value to array at index R and index C, we are just taking those values and adding it to sum, okay? And then our main method is just going to execute all those things. So if we run it, you can see here, it randomly populated it with these values, and we got 87 is the sum of our result, right? All right, so if we didn't fill the array and we just printed out the values, what would we get? Okay, you can see there that running it through debug mode, we're going to get the same value over and over again, right? Now, if we take it out of debug mode and actually run it, okay, let's see here, run without debugging, we get the same thing. That's because we have to put it into release mode, right? We build it and run it after we build it in release mode, run it without debugging, right? You can see that we've got different values here now, and they're not the same ones over and over, okay? So what that's doing is when you have it in debug mode, the compiler knows that it's in debug mode, and so it adds certain things to the code base to make debugging easier. And one is that of those things is filling up memory locations with a certain value. When you're running just in release mode, it doesn't do that, so we're just getting whatever happens to be there in memory anyway, okay? So if we cancel out of that and we put it back into our standard debug mode and build it, okay, and then rerun it again even without debugging, you can see that it goes back to those default values, okay? So that's just what happens if we don't fill the array. I just wanted to reiterate that C++ is more than happy to tell you what's in memory without you doing anything. So if we fill our array and run it, you can see there it prints us out our nice little grid of our values and prints us out our sum of the array. So again, that is an example of how to use row order processing and how to pass a 2D array in between functions. Okay, so we had our array created in main and we passed it into our various functions right here. So there's a good example of how to do that. So there you have it. In this lesson we looked at 2D arrays. We covered how to use nested loops to process them in row order traversal. We didn't look at column order traversal, but it's 6 of one, half a dozen of the other. Instead of going row by row, you go column by column, and then you go down the rows. And then we also looked at how to use that as a form of how to do image processing, right? How to create a modified version of a bitmap by taking each pixel and looking at what's going around that pixel and modifying the value of the pixel based on that, using the input masks. So we closed with looking at how to actually pass a 2D array into another function. And the key thing there to remember is that you can skip the size of the first dimension, but you should always include it as an additional parameter, okay? We didn't go into a lot of detail with a lot of functional examples. I just gave a quick one at the end there. So it's going to be your responsibility to apply what you've learned, think about it critically, and integrate these concepts into future programs and future assignments and all that. So that's it for Unit 3. Thanks.